greet you all. If you're on this channel, it means that you're on the right track. So today we are going to be discussing the paper, which is Physical Science Chemistry Paper 2, 2022. So let's start with the objectives. I'm not going to go through the instructions. You know exactly what you're supposed to do, but let me just emphasize on this. Sometimes when they give data sheets, some students leave the data sheet on the question paper, yet the data sheet which we are supposed to fill in, for example, a graph, and then they leave it in the question paper and they submit the answer sheet without that, for example, graph, which is supposed to be drawn, and then remove the paper from there, then attach it to the answer sheet. So please, if you find something like that, don't leave it in the question paper. Make sure that you tear it off and then include it in the answer sheet, because the answer sheet is the one which go for the marking or at the marking center, and then the question paper, they remain in your schools. Please don't leave the answer sheet or that extra paper which is supposed to be used from the question paper in your question paper. All right, let's start with the question 1. They're saying that which one of the following has the lowest boiling point? So if you look at this, all of them are straight chains, and these are the same functional group, which is you see that they have the same functional group, same homologous series. Therefore, what is different is the number of carbon atoms. So if you look at this, they're saying which one of the following has the lowest. This is the key point, the lowest boiling point. Therefore, we look at a compound with a low number of carbon atoms. So the answer is going to be, because this one has 6, this one has 2, this one has 4, this one has 8. So it's this one which has the lowest number. So they're saying that when ethene is converted into ethane, the type of reaction is, so in this case, if you look at this double bond, so when this double bond break one of it, it means that it's going to create, so it's going to be CH3, as they have shown it here. But how does it come to this? It means that the double bond will receive one hydrogen, the bond here, from the double bond. It's going to break in the middle. One comes this side, another one comes that side. I mean the parts, and then this one is going to receive one hydrogen, and also this one is going to receive one hydrogen. That's why you count them 1 plus 2, which is 3, and then here 2 plus 1, which is 3. So it means that since we are adding hydrogen on the reaction, therefore the answer must be hydrogenation. Is there hydrogenation there? So the answer becomes D. 1.1.3. They're saying which one of the following compound is which one of the following compounds in solution will change the color of bromo methyl blue? So what do you look at this? Sorry. What are you looking at this? This is an indicator which detect the pH which is relatively equal to 7. But remember, it can be on the side of alkaline or the side of acid. So this indicator measures pH which is relatively acidic. So in this case, we will look at a compound which is having relatively weak hydrogen ions ionized, or the pH is a little bit higher, which is near to the pH of 7. So if you look at this one, no. This one is acidic. This one, no. This one, no. So the answer is going to become this. If you look at it, first of all, it's an organic compound. Therefore, its ionizing power is low. So it means that it does not dissociate completely when dissolved in water. So its pH is a little bit higher. So it is a weak acid. So the answer becomes B. Then they are saying 1.4, two different samples of impure calcium carbonate of equal mass react with 0.1 mole per decimeter cubed of sulfuric acid. Assume that the impurities do not react. So it means that you are scooping out the impurities. So what are they saying? The graph below shows the volume of carbon dioxide produced for each reaction. So if they are looking for each reaction, when compared to reaction 2, which one of the following statements best explain the curve obtained for reaction 1? So if you look at, before we go that far, you'll see that reaction 2 is faster than the reaction 1. This one is slow. This one is fast. Why? Because it's more to the left. The more it shifts to the left, the faster the reaction is going to be. So you'll find out that what are they saying here on the question? They're saying that the temperature is higher in reaction 1. No. The surface area is greater in reaction 2. It's a gas. The amount of impurities is greater in reaction 2. If the amount of impurity is greater, then reaction 2 would have been slower. The amount of impurity is greater in reaction 1. Yes, that's why it means that you have fewer number of particles reacting. Therefore, the reaction is a little bit slow. Hence, it shifts to the right. So the answer becomes D. Then they're saying that the equation below represents the hypothetical reaction, that is A plus B gives you C. You see that the enthalpy change is negative. If the enthalpy change is negative, what does it mean? The reaction is exothermic. The activation energy for the reverse reaction is a key point. They even put it in capital letters. Reaction is 110 kilojoules per mole. Which one of the following is the activation energy for the forward reaction? For the forward reaction, they are looking for the forward reaction, but they're saying the activation energy for the reverse reaction is this. Okay, let's try to describe this, because sometimes students tend to fail this question. So now, if the reaction starts from here, it goes up. For the exothermic reaction, the enthalpy, the products must be lower in terms of energy because heat has been released. And then they're saying that if they're saying that the enthalpy change is -50 for this reaction. So this is the beginning, and then this is the end. So remember, final minus initial. If this is final, this is initial. So this becomes 50, but negative because final is lower than the initial. So it means that this is a change in heat of this reaction shown here. But they're saying that reverse reaction is 110. So if this is the, remember this is activation energy, yeah, this amount is activation energy, and the species which is as activation complex. So it means that now if I'm reversing, what's going to happen here? So this one becomes the activation energy, you see, and they say that this activation energy for the reverse reaction, when the reaction is going that side, is 110, because I start from low and then I end up in high. Therefore, the activation energy is positive and the enthalpy must be positive. All right. Now, the question is asking, which one of the following is the activation energy for the forward reaction? So it means that the activation energy for forward reaction is going to be this, from here to there. So that's going to be the activation energy, whereby what am I going to do? So I have to subtract this from this. So if I have 110 minus 50, so what is the remaining balance? The answer becomes 60 kilojoules per mole. So I come here and I look for that 60. So it becomes B. So that is the activation energy for the forward reaction. Then question 1.6. What are they saying about question 1.6? They're saying that the reaction reaches equilibrium at 25 degrees C in a flask according to the following balanced equation. So this is the balanced equation. They're saying that which one of the following will change the color of the mixture from pink to blue? So if it is in equilibrium, and then now you have pink, then you have blue. For this reaction to change from pink to blue, what must be done? It means that something must be added here. Something must be added here, or something must be removed here. So if you add something here, it's going to favor the forward reaction. If you remove something here, still is going to favor the forward reaction. If you add something here, it's going to favor the reverse reaction. If you remove something here, it's going to, so that it feels that it must fill that space which you have created of removing. And then if you add here, it means that it's too much, there's too much or excess. It's supposed to be balanced, therefore favors the reverse reaction. So now let's look at this and we see. First one, adding water. No, water will not cause that a big change in color. Cooling the flask, cooling, this is the enthalpy change is greater than 0. So cooling of the flask. Now adding sodium hydroxide, let me check and see. Adding sodium hydroxide will not cause this color to change. Then adding ammonium chloride. Do you have the chloride ions here? Yes. So if I add the chloride ions, because when ammonium chloride ionizes, it's gonna be ammonium chloride. It's gonna give me ammonium ion plus a chloride. So this chloride, it will be more here. When it's more there, what's going to happen? When it's more here, what's going to happen? It means that it's going to create a disturbance. And this disturbance is going to cause the reaction to shift to the right. And then the color will change from pink to blue. So the answer will become D. 1.7, they're saying that dilute nitric acid is added to distilled water at 25 degrees C. Okay, let me do like this. At 25 degrees C. Okay. Then they're saying that how will this affect the hydrozonium ion concentration and ionization constant, that is Kw, that is Kw means ionization constant for water. So at 25 degrees C. So they're saying how will this affect the hydrozonium ion concentration? Dilute nitric acid is added. Don't forget that this can only be changed by the temperature, not the concentration. Therefore, when it comes to you didn't change the temperature, you just added the concentration. Therefore, it means that it will remain, the Kw will remain constant, remain the same. So this could be the answer, and this could be the answer, because it remains the same. So this one becomes wrong, this one becomes wrong. But now, when you add dilute nitric acid, remember dilute nitric acid is like that. When it ionizes, it's a strong acid, it will give you hydrogen ions plus nitrate ions. So these are the ones, because it is dilute, so it's going to react to form the hydrozonium ions. So it means that the hydrozonium ion or concentration will increase. When it increases, but the Kw will remain the same. So this one becomes the most correct answer. 1.8, consider the ionization reaction 1 and 2. They're saying that when reaction 1 ionizes in water, it gives you this and this species. And the same species plus what? Plus water, it gives you species Y. So now what is species Y and what is species X? So remember, this is ionization. It means that it breaks down. So if it is like this, this is diprotic. It will ionize to give one hydrogen to the solution, and then that hydrogen is going to react with water to form this species, is going to ionize to give one hydrogen to, for example, like this, to the solution, and this hydrogen is going to react with water to form hydrozonium ion. That's why you have this hydrozonium ion here, then plus that species. Then it means that the species X is going to remain 1. Species X is going to remain 1. So if it remains 1, okay, let me show you what I'm saying. It's going to remain 1. So check, it was -1, but he has lost another hydrogen, so it becomes -2. These were 2 hydrogens. So if it loses another hydrogen, then it becomes -3. Before, it is phosphoric acid, is a triplotic acid. When it ionizes fast, Yes, it loses the hydrogen, then plus, now 2, I have 2 here, plus this. But now, because it has lost 1 hydrogen, so it becomes a negative. That's why it looks like this. Now, it ionizes again, ne? It gives out 1 hydrogen. So now it means that this is going to become 2, and then the number of hydrogens is going to become 1. And if it ionizes again, it's going to become this plus, now it's going to become -3. You see, it's -3. So basically, because I'm here on stage 2, this is going to be this species. So I come here, I look for that species. So I see this species here, I see this species. I see this species. So the answer is likely to be this, and this. But I say that when this X is brought here, it ionizes again. So when it ionizes, because it has been with 1 now it's going to become only this. So I look for this. Where is it? So the answer is this. Yes. So this one is also correct, but this was wiped out. Therefore, it becomes wrong. So the most correct answer here is A. So the answer becomes A. Then let's go to 1.9. 1.9. They're saying an electrical cell was set up using silver, using mercury, not silver, using mercury, and then the half cell and another half cell under the standard conditions. Don't forget that when you talk about the standard conditions, you must talk about 1 atmosphere. You must talk about 25 degrees C. Yes, and then you must talk about 1 mole per decimeter cubed. So, or 1 molar. So that's what they are saying. Which one of the following half cells, when connected to mercury, half cell will result in the highest potential? So it means that I have to look at which one is being oxidized more, the strongest reducing agent here. So I have to go to the scale, because here they're saying zinc. So let me say zinc, cobalt, and platinum, plus aluminium. So if I come here, zinc, cobalt, aluminium first. So it means that it's gonna give me the aluminium first. I think, yes. So it means that aluminium, zinc is here, then you find cobalt there. So it means that the other ones are down. So the most or the strongest reducing agent is gonna be aluminium. Therefore, when I come back here, I'll find out that A becomes the most correct answer. The following reaction takes place in electrochemical cell. Copper chloride gives you, that is in aqueous state, give you copper solid and copper plus chlorine gas. Now they are saying, which one of the following is correct for this cell? Copper chloride. Is it a galvanic cell? Not really. They are saying, why is it not a galvanic cell? Check the species this side. It's only 1 species. So this one can't be. Does it require the power source? Yes, because this is not spontaneous. It's not spontaneous. Reaction is, no, I've just talked about it. Copper acts as an oxidizing agent. Not really. So, let's look at it. Copper is up. See, copper is up and chloride is down. So copper is oxidized. Therefore, it becomes a reducing agent, because anything which is oxidized, it causes the other one to be reduced. Therefore, it becomes a reducing agent. So copper can't be an oxidizing agent. So the most correct answer is B, and then I will say that B is the most correct answer and the perfect answer. So we have managed to discuss about the first objectives, and we are sure that 20 marks can be obtained in a simple way. So use the same trick when you are writing your exam. Same trick, make sure that you pass. Yes. Don't forget to revise. Revise hard so that you don't regret in the paper. All right, let's go to question 2. Question 2 is about organic chemistry. They're saying that A2H in the table below represents the 8 organic compounds or molecules. Write down the letter of that represents compound that is. So before you start, you need to know to classify all of them. You have to know how to classify all of them. For the purpose of time, we might not classify them now. Let's go to the question straight. 2.1, which one is a keton? Which one is a keton? See, if you had classified them, you'd have known them very fast. So keton, no, alkene, alkene, no, aldehydes. Keton is here. So the answer is going to be E. They have the general formula of this. This is the alkynes. Don't forget that alkane is plus 2, alkyne is 0, and then alkyne minus 2, meaning that CnH2n plus 2, alkane, CnH2n, nothing you add, and then Cn, that is alkene, CnH2n minus 2, which is alkyne. And then if you come back here, it will give you the same thing, which is indicated there. So basically, let's look at this general formula now. They are saying kind, no, yin. That word yin. Remember the naming, it ends with yin. So F becomes the correct answer. Isomer of 2-methyl butene. Isomer of 2-methyl butene. So how many? This is the alkene. So it could be this. It could be this. Yeah, it could be this or it could be this. But now, how many carbon atoms are here? 2-methyl. Meth is 1 carbon atom. But is 4. So this is 1 carbon atom. This is 4 carbon atoms. So it gives us 5. If you count here, 1, 2, 3, 4. No, so that one is out. This is pent. Pent means 5. So 5 carbon atom, 5 carbon atom, and then same alkene. Also here it is the alkene. Therefore, the answer becomes C. The answer becomes C. Then it has the same molecular formula, as ethyl ethanoate. Ethyl ethanoate has the same molecular formula as ethyl ethanoate. So ethyl ethanoate, you find out that the answer becomes this. Why? Why this? Because ethyl ethanoate, sorry for that, ethyl ethanoate is an ester. And then this is a carboxylic acid. Therefore, it is a functional isomer. Is the functional isomer. And if you look at this, ethyl, it means 2 carbon atoms, and then this one, it also means 2. So 2 carbon atoms, which is 4. And then here, 1, 2, 3, 4. 4 carbon atoms. So they have the same number of carbon atoms. And ethanoate, it means that it has OO, 2 oxygens. And then also here, it has 2 oxygens. So basically, that becomes the answer. So the answer here is going to be H. They're saying that question 2.2, write down the IPAC name of compound A. Compound A. Now, if you go back and you look for compound A, IPAC name of compound A. So let's look at the longest chain. The longest chain is 1, 2, 3, 4, 5, 6. Ne? Single bond throughout. Yes. So it's 1, 2, 3, 4, 5, 6. So it's going to become hexane. Ne? 56. Let me do like this. It's going to be hexane. Hexane. Yes. If it is hexane, what is the 1, 2, 3, 4? Those are branches, but we're going to make this as a functional group. So it's 1, 2. So it's going to be 2 bromo 1, 2 dash 2 1, 2 1, 2, 3, 4 comma 4 1, 2, 3, 4, 5 comma 5. Yes. Try methyl, because all of them have 1 carbon atom. Trimethyl hexane. It's going to be 2 bromo. B comes before M. So therefore 2 bromo 2, 4, 5 trimethyl hexane. It's one word, ne? Yes. So that becomes the answer for that. Then they're saying that compound D, structure formula for F. What is the structure formula for F? So we go back here and look for the structure formula for F. So the structure formula for F is going to be, members, make sure that you write the structure formula. You write the structure formula. Because some people, they just write. And then some bonds are not shown. You end up losing everything there. So it is how many? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. But the double bond is on carbon atom number 2. 1, 2. Let me say 1, 2. So it is on carbon atom number 2. But the methyls are on carbon atom number 4. 1, 2, 3, 4. So there are 2 methyls. So when I have a carbon atom here, so this is a methyl. So I put hydrogens. Make sure that the bonds are 4 on each carbon atom. 1, 2, 3. So there's another bond. And you put the hydrogens in now. Don't leave it hanging, because when you leave it hanging, you lose a mark. You lose a mark. It is easy to lose a mark than getting a mark. It's not easy to get a mark, but it's very easy to lose that mark. So it is 1, 2, 3, 4, 5, which means spent. And then they're saying yin to in. Oh, it is yin, not in. So it means a small mistake has been done. Then this one goes out. Yes. So it becomes a triple bond. A triple bond. Yes. So it is 1, 1, 2, 3, 4, 5. Yes, which is pent. 2 is carbon atom number 2, and then yin is triple bond, and then they're saying that 4, 4, 4, 4, because this is the main what? The main the functional group. Therefore, it takes that direction. 4, 4, 4, 4. But what is this 4, 4 about? It is a methyl. Hence, I have these 2. So basically, that is it. Let's go to question 2.3. 2.3. They're saying the homologous series to which it belongs. Compound D, write down, yes. So it means that we need to see the homologous series to which compound D belongs. So if you look at this compound D is an aldehyde. So it belongs to a homologous series aldehydes. And its functional group is formyl. It could be formyl or carbonyl. So it is formyl. Let me go back to my color. Yes. So they're saying that, so the answer becomes here, homologous series, it is an aldehyde, while this one is the formyl or carbonyl. Then 2.33 is going to become the structural formula of its functional isomer. The structural formula of its functional isomer. So it means that if this is a keton, if this is a aldehyde, therefore it's going to become the keton. 1, 2, 3, 4. So it means that we just have to put structure formula. Yes, structure formula of its function isomer. So it means that they're going to be 1, 2, 3, 4. So I put there, and then I put the hydrogens. 1, 2, 3, 4. You see, I have to count and see if all of them are what? Are 4. So it's going to become 1, 2, 3, 4. Yes, this one is correct. 1, 2, 3, 4. This is correct. 1, 2, 3, 4. This is correct. 1, 2, 3, 4. Yes. So it means that that's the structural formula for that functional isomer. Then they're saying write the balanced equation using the formula for its complete combustion. Oh, No. Yes, I think I skipped. Yes, compound G, write down the APAC name of its chain isomer. APAC name for its chain isomer, compound G. G is butane. So what is the APAC name of its C chain isomer? So it means that I just have to change or to how to create a branch. So it could be butane is 4, so I have to make it 3. What am I saying? This is what I'm saying. 1, 2, 3, 4. So it's like that. It's a straight chain. But now I have to bring this here. So it is going to become 1, 2, 3, then a branch. Then I put the hydrogens there. But this is not the answer. They are saying the APAC name. Therefore, it's going to become 2-methyl, yes, 2-methyl propane. So it's going to become 2-methyl propane. 1, 2, 3, which is propane. Yes, and then the branch is on common atom number 2. Then balanced equation using the molecular formula for its complete combustion. So whenever they talk about combustion, your answer must add oxygen there. So that is the first answer you need to know, that it must add, and you leave space for balancing. It must add the what? The oxygen there. So now let's count it. Even if you use the other one or this one is the same thing. 1, 2, 3, 4. So it's gonna be C4. Yes. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the hydrogen is gonna be hydrogen 10 plus oxygen. That is the combustion which is happening, and then it gives you always the product is the same when you do combustion with the hydrocarbons is carbon dioxide plus water. So that's always the answer. So now you need to balance. If I put a 2 here, this is 8. So I put 8 here. Yeah, because this 2 times 4 is 8. So here is going to be carbon atom is 8. Isn't it? So now, if that is 8, so what about the hydrogens? Hydrogens, this and this, this and this is 20. 20, I have 10, I have 2 here. If I put a 10 here, so it's going to become 20. Now the problem is oxygen. How many oxygen do I have this side? I have 10. This is 16, it's 26. 26. 26. Is it 26? Yes, it's 26. 16? No. This 16 plus this is 26. So 26 divided by 2 is 13. So I'm going to put a 13 here, because 13 times 2 is 26. So yeah, I think it's balanced. Yeah. So this is a liquid, this is a gas, it's a gas, and this is a gas. Yeah, things balanced. Yeah. So basically, if the balancing is a problem, don't waste too much time there. Né? You can faster write the equation plus oxygen, whatever they ask you, the carbon compound give you, plus oxygen, you're gonna give the same product, which is carbon dioxide plus water. That's always when you burn hydrocarbon in air. So that's the product you're supposed to get. Please don't forget that. So when you finish, you go back and you try to come back and then you balance, because it might take your time before you complete the what? the paper. The last question, but on the list, on organic compound, or the second question. They're saying that define the boiling point. When talk about the boiling point, you're talking about the point at which the vapor pressure of a compound in a closed system is equal to the atmospheric pressure. Yes, the vapor pressure must be equal to the atmospheric pressure. So then that's when the boiling point, that's when the boiling point is what? Is reached. Sorry. Then they're saying that the boiling point of compound A, B, C are compared. Now they're saying A, B, and C. Check. Propane, butane, pentane. 3, 4, 5. Correct. It means that there's a good comparison there. How do the boiling point vary A to C? How do they vary? A to A, B, C. The boiling point is increasing. Then they are saying, give a reason for your answer. Yes. If they don't ask you why do they vary? It's because of the increase in the number of carbon atoms. So the intermolecular forces of attraction increases, therefore they require more force to be, more heat to break those bonds. And if you look at this, you'll find out that there is the London forces here. Yes. Okay. Then let's say, how do boiling point vary from A to D? A to compound C. A to compound C. We have seen it. Choose increase, decrease, or so we have said it increases. Explain your answer. You have given the answer there already, that it increases because of the increase in the number of carbon atoms, and then it increases the intermolecular forces of attraction. Yeah, intermolecular forces of attraction increase the random forces, yes, and then this will require more heat to break these forces, hence the boiling point increases. The boiling point of B, C, and D are compared. Let's see. B, let me change the color. Someone saying, why that color? Okay. B, C, and D. Is this a fair comparison? Let's check. This is 3. This is 4. Yeah. Why that color? You are correct. Let me use this. This is 4. This is 5. Butane. Methyl is 1 plus 4, which is 5. See, this is 5. So the number is not changing, but straight branched. Yet also the mass is also changing here. So we have 2 independent variables changing. So the answer becomes no. Is this a fair? It's not fair. Why? Because 2 independent variables, 2 factors are changing. So we want to know what caused what. So therefore, no. Give a reason for your answer, because 2 factors are changing. That is the nature of the chain. This one is straight chain, and then the other one is branched. This one is branched chain. So the nature of the chain, and then number 2, the mass, the molar mass is also changing. Boiling point of E and F are compared. State the independent variable. Boiling point of E and F are compared. Let's go back and see E and F. So in this case is E, F2, 2, yes, the number of carbon atom, but the functional group is different. This is alcohol, and then this is ethanol, which is aldehyde. Okay, what's the difference? This one is a little bit higher than this. So what causes this to change is basically the functional group. So the independent variable is going to be the functional group. State the independent variable, functional group. Write down the name of the strongest van der Waals forces present in F. F is ethanol. If F is ethanol, ethanol has no weak hydrogen bonds. That's why you see that its boiling point is lower than ethanol, which has weak hydrogen bonds. So because it has hydrogen bonds, the hydrogen bonds, therefore, it requires more heat to break it, while ethanol has no hydrogen bonds. Therefore, it only has what we call dipole forces. Yes, it has dipole forces. So that's the force which make it to be the strongest force in it. Which compound DE has the highest vapor pressure? And give a reason for your answer. D and E. D and E. D, this one, and E. Check the boiling point, then it will determine the vapor pressure, how much vapor pressure is going to be produced. So this one is 28, or this one is 70. The higher the boiling point, the lower the vapor pressure, and the lower the boiling point, the higher the vapor pressure. So it means that this one is going to have the higher vapor pressure. Why? Because it has the lower boiling point. Therefore, it produces vapor with less heat compared to this ethanol. So the answer is D. Give a reason for your answer. Because of the low boiling point. Think we are done with this. So 12 marks. If it appears, then automatically it means that this organic compound are very easy to pass. Yes, you can't go to the paper without killing this section of organic compound. Okay, let's go to question 4.1. Study the following incomplete equation for organic reaction 1 and 2. And then compounds PQ are organic compounds and T is an inorganic. Okay, this is an inorganic. All right, let's look at it. They're saying that reaction 1, write down the type of reaction that takes place in reaction 1. You have this is a bromide, sodium hydroxide, but this is concentrated. So it means that it is not in abundance. OH is not in abundance. Therefore, the OH won't be added to this. So it can't be substitution. It can't be substitution. So the answer is going to be, so this one is going to be removed because of the concentrated sodium hydroxide. So it means that P is going to be an alkene. So the answer could be elimination. You eliminate this bromide and the hydrogen, or dehydrohalogenation. Yes. Dehydrohalogenation. Why? Because we are removing the negative hydro, the hydrogen, and then halogen, which is the bromide or the bromine. So we are removing the bromine and we are removing the hydrogen, hence dehydrohalogenation or elimination. So they are saying that epoch name of P. So we say that P is going to be an alkene. So because I have 1, 2, 3, 4, 5. So it's gonna form 1, 2, 1, 2. It's gonna follow the mechanical fluid. It's 1, 1. So this one goes down. This one goes up. So it's gonna form here. So it's gonna be 1, 2, 3, 4. 1, 2, 3, 4. Yes. Remember, here there is this. Yes. So it's going to lose one hydrogen here. So it's going to double bond there. And this one also is going to be lost. One, two, three, four. Yeah. So the answer is going to be like that. But this is not the answer because they want the IPAC name for that. So it's going to be 1, 2. It's going to be 2 methyl. 2 methyl. Yes. 1, 2, 3, 4. Bute. 1, 2, 2 in. 2 in. So that becomes the what? The most correct answer. Name or formula of compound T. So because I lost this bromine, yes, the bromine will react with sodium hydroxide. Okay, let me show you. I lost the bromine. So now the bromine is there hanging. And also, you see here, there was a hydrogen. So the hydrogen is lost. So also hydrogen is there hanging. And then now this sodium hydroxide breaks down to form sodium bromide. So it means that the sodium will ionize. Sodium hydroxide will ionize. So it means that this and this, they will combine to form sodium bromide. Hence this. What about this now? So it means that these will also combine to form water. So this is T. And water is an inorganic compound. That's why they said an inorganic compound. Yes. Then they are saying that reaction 2. Now we're done with reaction 1. Let's go to reaction 2. They're saying reaction 2, you have carboxylic acid, which is the ethanoic acid, plus compound Q, which we don't know. It forms butyl ethanoate plus water. So the moment you say you find this ester, this came this from the ethanoate. What about bute? Bute is 4. So it means that that compound, the alcohol, must be butanol. So they're saying, write 2 conditions needed for this. The first one is heat. You need to heat. The second one, you must use concentrated sulfuric acid. You can use the symbol or you can write just because they didn't say that symbol. Structure formula for compound Q. Yes. You see, as I said, that is butyl. Butyl, it means that it came from alcohol. 1, 2, 3, 4. That is the bute. Because it is alcohol, therefore I put that. Then I inject it with the hydrogen ore. So you write the hydrogens, the hydrogen. Please don't forget to write the hydrogen. Don't leave it hanging. So it's 1, 2, 3, 4. So it's 4. This one must be, they say structure formula, must show the bond. So it must not be condensed. they want a structure formula, and that's where learners tend to lose marks in this organic chemistry. Yet organic chemistry is one of the simplest things you can talk about. Lastly, on organic molecules, they're saying that cotton wool soaked in this compound, which is an alkane. Yes. Because of 10 carbons and 22. It means that plus 2. Two straight chain organic molecules X and Y and Z are produced in test tube A according to the following balanced equation. They're saying that carbon, you have C10, HC10, H22 gives you X2X plus Z. Hey, yeah. Now, how are we going to know what is these 2X and what is Z? Okay, let's use this idea of you saying that 2X, if this is 10, 2X, I think. So it means that I'm gonna have yes, 2X, then I'm gonna have 4 plus 4 gives me 8. That's why I'm saying that 2X, which X is 4, 2X plus Z. Z, I'm remaining out of 8, I'm remaining with 2 carbon atoms. So therefore it means that it's gonna be 2. So I can't say 3, I can't say 5, because if the moment I say 5, it's gone. And then they are saying that state the function of aluminum oxide in the test tube. Basically, the function of aluminum oxide is to act as a catalyst, surface area for the reaction to take place. So basically, this is a catalyst. Then they're saying the organic compound XZ are now passed through bromine water. You see, XZ, at room temperature, the test tube B, only compound X react with the bromine. So it means that now this one is saturated while these two are unsaturated. Remember, bromine to react, it must have 2 bonds somewhere. Then they're saying that apart from the gas bubble being formed, state other observable changes you will see. The moment you pass unsaturated compound in bromine water, what is going to happen is the bromine water, bromine is red, actually. When you pass bromine in unsaturated compound, it's going to decolorize this bromine water and it's going to become colorless. Therefore, we can say that bromine water is going to be decolorized. It's going to be decolorized. So that the second observation you can see. And then they are saying that write down the type of reaction that takes place in test tube B. Write down the type of reaction which is taking place in test tube B. Let's go back and see. Because we're adding bromine here now, because this compound will come and then go through bromine water and then it's going to be decolorized. Because bromine is a halogen, so it's going to become halogenation. It's going to become halogenation. Then they're saying that write down the molecular formula for compound Z. Yes, write down the molecular formula for compound Z. So because Z, we say that is 2, and it cannot decolorize bromine water, and they're saying molecular formula, not structure formula, Therefore, it's going to be C2. Yes. Plus, it can't be 4 here. Why not 4? Because once I put 4, it's going to become unsaturated and it should decolorize the bromine. But they said here, it's only compound X which decolonizes the bromine or which react with bromine. Therefore, it's going to be 6, which means that is an alkane. CnH2n plus 2. So it's supposed to be 4 plus 2, which is 6, which is an alkane. Then they're saying that 4.2.5, write down the structure formula of compound X. Now they want the structure formula of compound X. Remember, these are 4 carbon atoms. And then these 4 carbon atoms, they decarboxylized. So now I will say C, 2, 3, 4. Remember, it was times 2. So double bond, then put the hydrogens properly. Put them properly. Yes. So that becomes the what? That becomes the answer for the structure formula. So you guys make sure that you try and try and try and try your best to do this organic chemistry because it has the. So let's go to question 5. They're saying that learners use reaction of magnesium carbonate with excess dilute hydrochloric acid to investigate relationship between temperature and the rate of chemical reaction. The balanced equation for the reaction is, so you have magnesium carbonate giving you hydrochloric acid plus magnesium chloride plus carbon dioxide and then water. The results were obtained represent presented in the graph below. Average rate of production of carbon dioxide in grams per minute versus the temperature. So please take note of this. It is not versus the rate or the time. It's not versus the time, it's versus the temperature. Yes. So here it's not the rate in seconds, it's the rate is measured in grams per minute. All right. Then they're saying that define the term rate of reaction. Rate of reaction is the change in the product with the change in time, or change in the concentration of the reactant with the time. So the rate, when you talk about rate means time. So you must know about that. So you should not repeat rate. So state 2 conditions that must be kept constant in the investigation. Since we are using a solid here, so pressure might not work out. So we can talk about the surface area. The surface area, meaning that whether they are grains or it's granules or fine. Yes, surface area. And then you can also talk about the concentration of the reactants. So basically, concentration is a good answer, and also surface area, then concentration. They're saying use the collision theory to explain the relationship in the graph. So what's happening in the relationship with the graph? If you look at it, you see that as temperature increases, the average rate of reaction is also increasing. So the graph is showing you. Remember that whenever the graph is going like this, it shows the graph for the products. So basically what you need to talk about here is the higher the temperature, the higher the kinetic energy. So your explanation must have the word high temperature, high temperature. You must equate it to high kinetic energy. And then if the kinetic energy is more kinetic energy, meaning that the particles have more kinetic energy, therefore it means that you have the word, you must talk about more effective collision, more effective collision. But the collision must take place per unity time. So high temperature, the higher the temperature, the higher the number of particles with more kinetic energy, and the more effective collision per unit time it will happen. And then what happens if more effective collision, there will be higher rate of reaction, or increase in the rate of reaction, increase in the rate of reaction. So basically the key points are when I'm marking high temperature correlated with more kinetic energy, more particles will have to collide effectively or per unit time, or more effective collision per unit time, and then there will be increase in the rate of reaction. Then they are saying that a learner obtained a graph using 5 grams of magnesium carbonate with excess hydrochloric acid at 40 degrees C. Calculate. They're saying calculate. What are you calculating? Calculate the time taken for the reaction to take place. Now, if you talk about time taken for the reaction to take place, okay. I'm just looking for a space here. Okay, let me use this. So what are you going to write here? What are you going to look for? Because now time there is nothing given here related to time. So what you need to do is to relate it to rate. Remember, when you say rate is going to be equal to change in the concentration over change in time. So if I have the rate, I have the concentration, I'll be able to find the time. But here from the graph, they say that this is average rate. So I can find the average rate here. So let's start. How am I going to find the concentration? So we're going to use the product, because this is the carbon dioxide. So we have to look for carbon dioxide. But we don't have anything we can start with related to carbon dioxide. Therefore, I have to use this, and after that, I use the mole ratio. So let me find the RFM of magnesium carbonate is going to be equal to, magnesium is 24 plus carbon is 12 plus oxygen is 16 times 3. So the answer is going to be 84. So this is the 84. So now if I come here and apply my equation, I'm going to say mass, number of moles is going to be equal to, number of moles is going to be equal to mass over molar mass. I have my mass. The mass is given here is 5 divided by the molar mass, which is 84. So when I get the answer here, the answer is going to be 0.06 moles. These moles are for this. So now from here, I need to do a mole ratio, magnesium carbonate to carbon dioxide. So if you go back to the equation, you'll find out that the mole ratio is magnesium carbonate with carbon dioxide is the mole ratio is 1:1. Therefore, I'm going to have 1:1. So if I have 0.06, I'm going to also have 0.06. So now, because the graph is giving us in mass, in grams, therefore I have to change this. I have to change it, and then change this moles into mass of carbon dioxide. Therefore, I'm going to use the same formula again. This number of moles is equal to mass over molar mass, whereby number of moles, I have them for carbon dioxide. 0.06 is equal to mass, of which the mass I don't know, I'm looking for. And then the molar mass is equal to carbon dioxide is 12 plus 16 times 2, which is 32 here. 32 plus, which is 44. Yes. 44? It's 32. 32 plus 12 is 46. Is 32 is 44. Yes. So it's gonna be 44. So I cross multiply. So M is gonna be equal to this times this. So M is gonna be this times this, which is 22.64. These are the grams. So now from there, I think I'm able to get the answer. If I apply, let me use this space. If I apply, come here. If I apply this now, you'll find out that I'm gonna have to rate. I have to go back and find out what's the rate here. Let's assume that it started from 246. 246. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each is 1, 1, 2, 3. So it's 3. And then this one, it does not reach 6. So it's 4. So basically it's 6 minus 0.06 minus 0.003. So when you subtract, you have to subtract, okay, this minus this, so that I get, because it didn't start from 0. So when you subtract, is around 0.5. So it's around. So the average rate based on this is gonna be around, average rate is gonna be around 0.52, which is almost 0.5. So now we are saying that average rate 0.52 minus is equal to the grams, changing the grams, started from 0 is 2.64 over the change in time, over change in time, which gives me change in time is gonna be this divided by this, which is 2.64 divided by 0.52, which gives me around 4 point something. Yeah, around 4 point. You can use the calculator and then find out the actual answer, 4 point something, but this is minutes, because this time they said they are measuring this in minutes, grams per minute. So the answer must be minutes. Then, so that's the actual answer. So 4.8. Yes. So now let's look at this. Let's look at this. Let's look at this 4.8. So after calculating is 5.0, 5.1, 5.07, okay, 5.1 minutes. So now they're saying that molar mass of molar volume of this compound carbon dioxide at 40. So what is the molar volume of carbon dioxide at 40 degrees C if the volume is 1.5? So don't forget that the molar mass still is going to be the same. Number of moles is equal to mass over molar mass. Obvious, I have the number of moles here. We calculated them here. So it's going to be 0.06 is equal to the mass. They are looking for the molar mass. So do I have the mass? Yes, I have the mass. Okay, let's not use the mass because they are looking for molar volume. So let's use the volume over molar volume. Do I have the volume? Yes, I have the volume, which is 0.5 out of the molar volume, which I don't know. So the answer is going to be, and you calculate, it's around, yes, 25 decimeter cubed, 25 decimeter cubed in each mole, yes. So that's the answer which is supposed to be given there. So if you look at these questions, it's easy to answer these questions and we are able to get all the marks. Let's go to the last question of this section. The graph below represents the Maxwell distribution curve for carbon dioxide at 40 degrees C. They're saying that redraw the graph on the answer sheet and label it A. On the same axis, sketch the curve that will obtain carbon dioxide at 20 degrees C. So it's happening at 40. So at 20, remember this is kinetic energy. You understand? And then if I do this, you will find out this is the number of particles with sufficient energy. So now, when you lower the temperature, it means that the number of particles with sufficient energy will decrease. Does not mean that the number of particles in the reacting vessel have changed. No, they are still the same, but they have to redistribute themselves to see that which one will have enough energy, which one will not have enough energy. Because I've lowered the temperature, and temperature increases the kinetic energy. Therefore, I'll have fewer number of particles which will have the sufficient energy to collide to form products. Therefore, if I redraw this graph, I have to start on the same graph, same point, and then it goes up. Yes. And then the number of particles with sufficient energy will not be the same, will be lower. So something like that. It must be straight, ne? It must be correct, nice, ne? Yes. So this one, it will become the graph which is drawn, which is B. So that's how it's supposed to be done. So if you check here, the number of particles with sufficient energy, in this case, they are lower. While in the first case, with the high temperature, they are higher. What if they say that is 4 here and then redraw showing the temperature at 60? Therefore, it means that you will increase the number of particles with sufficient energy. Therefore, it will come like this and comes like this. It means that it has more particles with the sufficient energy. So it means that if you look at the shaded area, see that there are a number of particles which have sufficient energy. So that marks the end of this, the 50th question. Let's go to chemical equilibrium. Chemical equilibrium. Question 6, they're saying that initially 4 moles of hydrogen, yes, and 4 moles of iodine allowed to react in a sealed 2 decimeter cubed flask according to the following equation or balanced equation. Hydrogen plus iodine giving you hydrogen iodide. The enthalpy change is less than 0. So meaning that this reaction is exothermic. So we have to know that. Now they're saying graph below shows the concentration of this and this versus time. All right. Question 1, write down the value of y. The value of y is divided by 2. So basically it's gonna be 2 decimeter cubed per 2 moles per decimeter cubed. It's gonna be 2 moles per decimeter cubed. Yes. Some people might ask, where am I getting this? Is number of moles is equal to, concentration is equal to number of moles over volume. So you have the number of moles, which is 4 divided by 2, which gives me the concentration to be 2. Yeah, so just in case that you didn't get it, how did I get that? Okay. So that's why I'm saying that the answer is gonna be 2 moles per decimeter cubed. All right, state the Rectian's principle. Here, when you are talking about the Rectian's principle, you're supposed to talk about the stress which is being introduced and how is this stress being wiped out from the system, and how is the system going to favor the what? Is it the forward reaction or the reverse reaction? So how you can say is, let me just state it for you, that when equilibrium in a closed system is established, yes, the system will reinstate a new equilibrium by favoring the reaction that will cancel or will oppose. You can say cancel will oppose the disturbance. So basically, that's what you're supposed to talk about. And then, so question 6.1.3, they're saying that change were made to temperature of the flask at T2. At T2, what flask was the flask heated or cooled? Let me check. Remember we said that this is exothermic. And then if you look at this, it is increasing. It didn't reverse, it increasing, the products are forming more, and then the reactants are disappearing. Then it means that because it is exothermic, it will be, the forward reaction will be favored by decrease in temperature, because it is an exothermic reaction, doesn't need heat. So when you decrease the temperature, if you cool it down, therefore the forward reaction is going to be favored. So that is the answer. So it's exothermic. Why? Is because it's favored by lowering the temperature. Therefore, the forward reaction is going to be favored as an explanation. Equation below represents the reversible reaction that takes place with the nitrogen dioxide is converted into dinitrogen tetraoxide. And then they're saying initially, is calculating. Initially, you have this X moles of nitrogen dioxide is sealed in 1 decimeter cubed container at 350 Kelvin. When the equilibrium is established at a temperature, yes, you're saying that 0.8 mole decimeter, 0.81 moles dinitrogen tetraoxide is present in the container. Write down the meaning of the reversible reaction. Reversible reaction is when the products can be converted back to reactants. Don't tell me that reversible reaction is a reaction whereby it can be reversed. No, the products can be converted back to reactants. Show that the equilibrium constant for this reaction is given by this. So this is like a proof. You have to prove that the Kc is equal to that based on the information which is given there. So in this case, we are going to use our Rice method, depending on what your teacher taught you. So let me draw it here. Let me choose the black color. Draw. Okay. Hope they're enough. Yes. So if I put here nitrogen dioxide and nitrogen dinitrogen tetraoxide, then I put my rice here. Rice here. Yes. So it means that I'm short with one. Okay. Let me just rub off this one. Okay, now let's start. Fill in the information. What are they saying? They're saying that x, initially it is x of this. So what are we supposed to do here? So since we started with x, so we shall come here and say that we started with the initial. This is a ratio. All right, if you are saying a ratio is 2/1. So I'll come here and I say is 2/1, but this one started with x, but because this is the product, it starts with 0. Now they are saying that 1 decimeter cube, that's the volume. You say that when equilibrium is established at that temperature, 0.81 moles of dinitrogen tetraoxide is present. So at equilibrium, yes, you'll find out that 0.8, yes, 0.8 is there. At equilibrium, 0.8 means that that is what is produced. Therefore, 0.81, that is what was produced and is the same thing what is at equilibrium. So if I have what is used or what is produced is 0.81 and it's 1 mole, what about when it's 2 moles? It means that I'm going to say 0.81 times 2 because I have 2 moles here, which gives me 1.62. Yeah, so those are the number of moles which were used. So now I need to know the number of moles which remained at equilibrium, but I started with x. Therefore, I'm going to say x minus 1.62. So those are the number of moles which remained. So now, what is the concentration at equilibrium? This is the concentration at equilibrium. So if I say that's the concentration at equilibrium, therefore, I will say, because if you go back here and we are supposed to divide it with the volume, but the volume is 1 decimeter cubed. Remember that concentration is equal to number of moles divided by a volume. But now the number of moles is this, and the volume is 1. A number of moles is that, the volume is 1. Therefore, it's going to be exactly the same, 1.62, 0.81. Then now, they're asking you to write the Kc. Kc is the product, both of them are gases. Therefore, I'm going to say Kc is equal to the product, which is 0.81 divided by x minus 1.62 But remember, this is 2. 2 number, the number of moles 2. So we power it to 2. So this, does it resemble the expression they gave us? Yes, 1.81, 1.81. Then they're saying that x minus 1.62 squared. X minus 1.62 squared. Therefore, our answer becomes correct. Then we go to the second equation, saying that 0.79 moles of dinitrogen tetraoxide is now added to 0. So it means that now we have added this. Is added to equilibrium mixture below, and then when the new equilibrium is established, it was found out that nitrogen dioxide increased by, it increased. So you need to take note of this because there is an increase. All right. Let's go back and then we do our same rice method. Yes, same rice method, whereby I have nitrogen dioxide and then nitrogen tetraoxide. Then I have rice, which is ratio 2:1. Then I have rice C E E, whereby here I have the initial. Now, the initial in this case, what did we start with? In this case, they say that 0.1 was added. 0.79 moles of this were added to nitrogen dinitrogen tetraoxide. So it means that when I go back to this, yes, to this which was at equilibrium, I added, so I have to add 0.97 because they said 0.79 was added when the mixture was equilibrium. So it means that I'm going to say 0.81. So it means that I've started with 0.81, yes, plus 0.79, yes, 0.79, yeah. So that's what I started with. What are they saying? Then they say that when equilibrium is established, it was found out that 0. So what about the other side? It means that before I go there, it means that this one didn't change. So it will remain x minus 1.62. So I come here, I write it there. So it's going to remain with the, oh, sorry. This is 1, this is 1 more. It's 1 more. And then this one is, as I said, 0.81 plus 0.79. And then now, this side, this one didn't change. It only changed at equilibrium. Therefore, it's going to be x minus 1.62. Yes, I got it there. I got it from what we calculated. Got it from what we calculated at equilibrium. Yes, so you should not be confused. Now, they are saying that, what are they saying? That they're saying that when the new equilibrium is established, it was found out that nitrogen dioxide increased by, at equilibrium, it increased by. You see, at equilibrium, yes, at equilibrium, it increased by 1,2. 1,2. Yes. So if it increased by 1,2, what is going to be the answer? 1,2. Therefore, I have to add it there. I have to add it there. So it increased. Let me first draw a line. So at the first, it was like this. So it's going to be x minus 1.62 plus what added? They say that 1,2. So 1.2. So what is the answer here? The answer is going to be x minus 0.42. Yes. And then if you add here, what is it? Answer is going to be 1.6. Yes, if you add the two. Yes, so what was used? What was used? So if you go back here, you'll see that they're saying that if this 0.79 moles now added to the equilibrium, and when the equilibrium is established, the amount was found to be this. So if they're saying that it increased by 0.2, then it means that half of at what changed, it increased by this. It means that that is what changed. It increased by that. It increased by this at equilibrium. So if it increased by 1,2, see 1.2. Yes, 1.2. Let me check. It increased by 1.2. Yes. So that's why now this brings up the real aspect that if I subtract this minus this, this, so if I add this, because it was added, it was found out that this is what was added. Therefore, I have x minus 1.62 plus this. That's why you're able to get this. And then now, because I have this is 2 moles. And then what about this side? It's going to be half of this, which is 0.6. Now, if I subtract here, it's going to be 1, because I have to subtract here to check, see what was at equilibrium, which is 1. Then now, what is the concentration? So now we are looking at the concentration at equilibrium, whereby it's the same. They didn't change the volume. It's the same volume, which is 1 decimeter cubed, meaning that it's going to be x minus 0.42 divided by 1. If it was 2, divide by 2. But in this case, it's 1. And 1 divided by 1. So his answer is 1. And then it's going to remain x minus 0.42. Yes. So now, after that, I apply the Kc. Kc is equal to product, which is the nitrogen tetraoxide divided by nitrogen dioxide, but this one is squared. But I found my Kc before. Value is 0.81 divided by x minus 0.81 divided by x minus 1.62 squared is equal to, now this is the Kc. This value goes to the Kc, and then now I need to put the expression for this, which is 1, yes, divided by x minus 0.42, yes, 0.42, which is squared, and then you solve for the x. So you can cross multiply, and then you form an equation which you can solve the x. So finally, x is equal to 12.42 moles. So that becomes the answer for this question. Yeah, the value of X is equal to 12.42 moles. Yeah, let's go to the next question, which is the acids and the bases. Acids and the bases. When you're talking about acids and bases, two